Let's dive into some common alarms because you guys take a ton of support calls, right? What are some of the common alarms that you would see, maybe from the controls that the technicians need to check? Because you got controllers now on here, so they got to go up and look at the alarms. First step is, what are some of the most common alarms? How do they look at it, and how do they maybe approach an alarm before they make a phone call to you guys? You know what I mean? We want to build a confidence in these technicians to be able to try this stuff. So, what are some of the common alarms that you see?
So usually it's the most commons are related to the water system.
Okay.
So it would be either pump failure. So pump failure means that the proof was not made. So the PLC sent out a DO, a digital output to turn the pump on. It did that, but it did not receive proof through the current. We use a current switch on our Trillium. So
Okay.
if the current equals 0 and the controller is asking the pump to start, and after 10 seconds, if there's no current being pulled by the pump, then the controller assumes that the pump is dead. So that's a common one.
Okay.
Then
Okay. So when they get up there, let's talk about this call. So this has happened. So we get the digital input. It said, "Hey, we need that pump running, but we
mhm,
that current sensor is not sensing any current through that wire."
mhm.
So I'm assuming one thing, that current sensor could be dead. So you go up and you actually check it with a meter. What should they see when they're checking the current sensor?
Well, so let's say that we get that alarm and we're standing in front of the unit. So obviously the first thing will be to check that the pump is not running. Like we will touch the
Yeah.
pads or see that there's no water. So there's
Yeah.
no water. We have to assume that the pump is not running.
Yep.
Um, So the second thing, I always like to start with the free/cheap things to check. So the next easiest thing to check is the breaker. It could be that the breaker for the pump is down. So the
Huh?
pumps have their individual 120 breaker. It could be that the breaker is down. Now, if the breaker is down and you flip it on and the pump starts, then you should start thinking about why did it trip. I mean, not just
Yeah.
ignore
Just turn
it.
and walk away. That there's something
Yeah, yeah,
caused it to trip.
yeah, yep. And then yeah, if you check all of those, let's say the free stuff, you would have to assume that the pump is bad, and then you just need a replacement pump. So in that case, we have what we call the discrete system. So you literally take a garden hose, plug it into the side of the unit, and then we
Okay.
just dump water constantly over the pads, and then you can order a new pump, but at
Yeah.
least you have some capacity.
Okay, so
So
that's great. So we're still on this call. You check the breaker's tripped, you turn it on, and it runs fine. What are
mhm,
some of those checks that cause it? Because that's overcurrent. The pump must have been overamping.
most likely.
So it could be the breaker's bad for sure. That, don't get me wrong, the breaker could be bad, but most likely it's something going on in the pump. What would cause the pump to cause high amps to trip that? Say,
So the most common, that's a good question actually. One of the most common reasons why the pump trips on high current is uh, because of Ohm's law, unfortunately. So what happens is if your unit is, let's say, rated for 230 volts, but the customer has 208, sometimes people believe that's close enough. That's not that bad, right? But it is. So it turns out that we have a transformer in there, which is a linear device. So it would, if at 230 you get 120 or 115, at 208 you're going to get like 90. So your pump will run, but because of Ohm's law, now you're going to be pulling significantly higher amperage. So it will run maybe for a week, a month, who knows, maybe even longer, depending how long. But at some point, you will have a problem.
that's
Um,
awesome.
the other thing that could be is that the transformer in our panel is wired incorrectly. So we use a multi-tap transformer that can take for 60, 230, or 208. So it could be that somebody by mistake wired in the wrong terminal. So again, you will be getting a lower voltage. So one thing that I like to ask, that I ask or text to check, is take your meter, go into the main transformer, which is a big black, is a large transformer in the panel, and just make sure you're getting 115 out of it, because that's a good starting point. The PLC and the rest of the devices are really tolerant to fluctuations in voltage. So like the PLC can take anything from like 36 to 20 volts AC. So even if you wire incorrectly, those PLCs have a huge range. So they're the
Okay.
same thing as the fans. The fans have a huge range. The fans can do uh, they can do 200 to 230. So they don't really care. So you're not going to hurt them. Nothing is going to happen. But certain devices do care,
Like the pump. Like the pump.
like the pump. Yep, exactly.
Awesome. That's a great tip right there. That's huge. That's going to save lots of technicians time understanding those tips there.
Mhm.
Al, what about you? What are some of the alarms or maybe some of the common um, fault codes you would see that you've seen up for some of your customers?
Yeah, I think the pump and the float are the two most common. Another one that we get kind of often is that the unit is overflowing, right? The actual sump is overflowing with water. So what would cause that? Well, essentially you've got a drain valve that's closed and you've got a makeup valve that's staying open. The unit's calling for water, the sump's full, but it doesn't know that. So could be a couple things. You could check the drain valve. Maybe the drain valve is being commanded open, but it's stuck in the closed position. Could be the float switch, like we talked about earlier, but perhaps the float switch is upside down or defective. It thinks that the sump is empty, and it's calling for more water. Or it could be the makeup valve, kind of like we touched on earlier. There's a piece of debris or something that's keeping that solenoid stuck in the open position. So yeah, I think that's a common status. The unit is overflowing. So what could it be? And usually I get Greg on the phone with the technician, and
Yeah.
we go through a few steps and try to eliminate.
Awesome.
Mhm.
Awesome. Greg, what would be another a fault code that you would get on your controller? So we talked about the pump. So the demand's there, but the pump's not running. So the current's not running it. And we talked about voltage. Because what would be another one a technician would maybe roll up and then it's getting a call and it's not working. The system's going off on high pressure maybe or whatever the call
Mhm.
is. What's another code?
So another code that we get is called makeup water failure / no water in the system.
Okay.
So that is literally an alarm that our unit gets, and that one could be multiple things. So the first thing you should check is make sure that the pipe going to the unit has water. Just because the unit says that there's no water doesn't mean that there's no water in the state or in the building. You know what I mean? Like, you have to make sure that there's water in that pipe. If you have water in the pipe and the unit is telling you that there's no water, it could be because the makeup valve has failed. The makeup valve is 24 volts AC. So the first thing you will do is take your meter, make sure you're sending 24 volts to your valve. Now, if you're sending 24 volts to your valve and it's closed, it's a normally closed valve, should be open. So obviously you will know that it's a valve. Now, there could be another interesting situation in which the unit says that there's no water in the system. You get that alarm, but the unit is overflowing with water. So that just makes no sense. So what has happened is the only way the unit knows if there's water on the basin is with the float. So if the float is down and the makeup is open for 10 hours and the float never closes, the unit is going to think that either there's no water in the building or that your makeup has failed. So the solution for that is obviously check the float, replace the float if needed. But yeah, that's a common alarm that we get, and it's usually related to one of those things. Another thing I wanted to mention is the concept of normally open and normally close. And I don't know if that's used a lot in our industry and other things and in compressors. I assume it has to be for valves, but a normally closed device means that if you remove all power from it, it will close. Most that we're talking about valves here,
Yep.
and a normally open device means that it will fail open, meaning that if there's no power applied to it, it's open. So our makeup valve is normally closed. So when you apply power to it, it opens. Now the drain valve is normally open. So if you're running the unit in wet mode, you expect it to be closed. So for it to close, it needs to have power. So sometimes we get calls saying, well, the unit is working backwards because I'm putting my meter on the drain valve, is running wet, but the drain valve is energized. Because I guess the thought is that, well, I'm applying power to it, so it stays closed. But it's a normally open valve, so it actually needs power to it. So it's correct for it to have power all the time. So yeah, I get people get confused sometimes with that concept.
Okay, so just so clear, when the is running, the pad's working, we're around 72, and with the
Mhm.
pre-cool sensor, whatever, it's okay. We're calling, we want to cool the pad, efficiency, right? We want to wet the pad. That outlet the drain outlet should be closed, so we're reusing that water. Is that correct? And when
Exactly.
the pad's not, all of a sudden the temperature drops down to 65 Fahrenheit or down to 10, 12 Celsius, all of a sudden we don't need any water. That's going to be open, so we're drain it so there's no bacteria building up in the water or in the gas cooler, so Legionnaires' disease and all that stuff. So you're getting the water out of there. So that's kind of the idea, right?
Exactly. Now, the make-up valve can be either energized or de-energized, because remember, as you make up during the day, that valve will get energized once in a while to open, to make up water. So the drain valve, if you're running wet or pre-cool mode, your drain valve should always be energized, unless you're draining, obviously. And the makeup would be opening and closing depending on your evaporation rate.
Yeah, because we want to fill it up. We need to keep. We got to get a rate in there when we're calling for that. Okay, I love that. Anything to add, Al?
Nope. Yeah, I think Greg's got it. I think the way to think about it, if it's confusing at all, is that the default state should be dry. So if you lose all power, the unit should be dry. So a dry unit means a closed makeup valve and an open drain valve.
I love that. I also get lots of calls on like how are they set up? So we talked about a couple of troubleshooting things. You guys program them from you have a program in them from the factory, and then some manufacturers will use their own programming, sending a signal to the. Do you want to talk along the lines of that? Because I'm sure some of your customers will be using your program potentially, and some of them will be using that CO2 manufacturer's programming. What are your thoughts on that, and how do you guys work with both customers?
Yeah, I would say probably 99% of our units have the standard controls configuration, which is our unit PLC controls the water side system. So the makeup valve, the drain valve, the float switch, and the pump. That's all handled by the onboard PLC. And then as far as an external control signal, we're looking for the fan speed signal from the customer's rack controller. And typically that's a 10 to 0 volt signal. So sending the unit 10 volts, the fans are off. Sending it 0 volts, the fans are on completely. And the logic there is that if the wire gets cut or if there's some failure, we want the fans to fail in the full on position. So that's the most standard configuration. It's the most straightforward. Like I said, again, the unit PLC handles the water side controls, and the customer controls the fan speed to maintain their discharge pressure. The next level up from that would be like a Modbus or a BACnet integration. So in that case, we provide the relevant interface in the PLC, whether it's Modbus or BACnet, RS-485 or BACnet IP. And then the unit's the customer's controls contractor can do a full-on integration. They'll be able to see many more points, many more alarms, and then they can get into more nuanced control. They can command the pump on and off themselves. They can see more of the readable values and such. But I think we're probably moving more in that direction, but it's still a relatively small subset of customers that are taking that extra step and doing that full-on controls integration.
Okay. And Greg, I've been at multiple events where you'd have your unit there and you would show the controls through the technicians and talk about them. So what are some of the tips for a technician going up and seeing these new controls? Like do you stick with one brand, or do you use a few different brands for the control side?
So on our units, we currently use Carell.
Yeah.
We've been using them for like 12 years, I want to say. Before that, we used Mitsubishi for us.
Okay.
Very little amount of time. So there are some units out there with those. In the future, we might be switching to something new. I mean, we haven't, we don't know right now, but yeah, we use Carell. Everything is Carell, like the sensor, the temperature sensor, it's Carell. Obviously, that our controller is really small. It basically just controls the water system. And then obviously the fans that have their own PLC in them.
What's the login for a technician? So if they need to go in and log in and look at stuff, is there a specific code or a password they got to put in to get in to take a look at it? You do need the manual for this before you start playing around with stuff. You need to read the manual for the controls to understand it. But is there a password that they need to use to get in?
Yeah, so we have the technician password is 1703, and like I said in many meetings, we chose that because before the Trillium, most of our business was with ammonia. So the molecular weight of ammonia is 17.03. So that's why we chose that number. We thought that everybody will know it, but obviously in our industry, it's not that popular. We should have used probably CO2, whatever the weight is. So yeah, that way you will never forget. I mean, people tell me, yeah, I remember that, and I just Google molecular weight of ammonia in the phone, and that's how I know the password. So yeah, it's just a good way of remembering that. And that password is needed if you wanted to do like changes to like the timers, or if you wanted to change how often the unit dumps and things like that. And the things that you guys were talking about before, how we control the unit. So there's multiple ways you can control the fans on this unit any way possible. You can use 0 to 10, like Al was mentioning. You can also use 10 to 0. You can use 4 to 20 milliamps. You can also control it via Modbus or BACnet, or you can. And then we have an option with a self-contained system that you can buy a pressure transducer. You put it on the pipe, and then you run your own PID loop on the controller. Or we don't do that for CO2, just for safety reasons and operational reasons. But yeah, there are multiple ways, and I mentioned that because sometimes brand new units come configured the wrong way from our factory. It could be a mistake in how the unit was configured from how the customer asked for 4 to 20, but then it turns out they have 10 to 0 in the field, things like that. So that is something that you can easily change on the PLC. And the problem is that if you don't know that, the unit is just going to run at full speed forever because no signal, the fans are designed to fail at full speed. So at least you have some cooling, but obviously you won't have control of the fans. So that's just a good thing to keep in mind. If you have a new unit and no matter what voltage you send to the fans, they still run at full speed, it's most likely 90% likely that it's just set up incorrectly.
Great for the summertime, not good in the wintertime.
Exactly.
Okay, so man, I love this conversation. We could go on for days, but I got a couple of good ones that I really, even in the industry, like a lot, even the supermarkets, they run them the same way year round. You know what I mean? Like there's low ambient, and then we in with CO2, you got to have your gas cooler fans, your water, your high pressure valve, your flash gas bypass, all working in sync. You know what I mean? If you want a good, efficient running system. One of the big things is seasonal efficiencies. And this is where I have lots of conversations. Well, should the summertime set points be different than the wintertime set points, and transitioning like to those high peaks to those cold winter months? What are you guys' thoughts on that? Like for different seasons, should there be potentially different set points in the winter versus the summer for your gas coolers?
So I don't know, Al, do you want to start, or do you want me to?
I would just say that the controls have a low ambient safety built-in. So anytime the ambient temperature is below 40 degrees, you're automatically going to be locked out from the water system. We don't want any water entering the unit or flowing through the unit when it's below 40 degrees. So that's automatically built in. And typically your adiabatic set point, like I mentioned, is going to be something in the 70s. Even if it's in the high 60s, you're still not going to probably see that in the low ambient conditions. It's funny. We size these heat rejection devices based on design day. Everyone's worried about peak ambient conditions. I have customers using ASHRAE 10-year extreme conditions. But honestly, we have more issues with stable control during the colder months. I don't think we've ever had an issue meeting capacity in the summer. It's always stable operation in the colder months. And then you add in things like, heat reclaim and other strategies like that. And there's really just a very, very small load on these gas coolers. And we're asking the fans to run stable. So I think it's a good question, and it's an important topic, that low ambient operation. Like I said, the unit's going to be dry, so it mostly comes down to the fan speed control and that PID loop that the rack controller is using to control that fan speed. That's the most critical part of stable winter operation.
Okay, Greg, do you have anything to add to that?
Yeah, so like Al was saying, sometimes our customers think that a bigger unit is better, more capacity, but the problem is, in the winter time now, the unit is significant, especially in places like that gets really cold, like Canada. Oh, yep. Yeah. So now it's negative 40, which is, I guess, normal for you guys.
Oh yeah, it's
Negative
all
40.
summer long, all year long.
So now you can sneeze on that coil and you will see a drop in your head pressure. That's how that happens. So, but like Al was saying, PID control, PID loop tuning. That's one of the main things that customers need to keep in mind if you want to control these units when it's cold. Luckily, EC motors, unlike AC motors, they have a really low minimum speed. Like ours, you can ramp all the way down to 5%, which is awesome. As you probably know, some AC motors have minimum speeds of 15, 20, even more than that percent for oiling reasons and some other reasons. So it is important to take advantage of that because some of the cost of that fan, I mean, customers are paying for that technology, so I think they should use it. So tuning the PID loop on a cold day, that's important. I know that startups are usually, or they could be during the summer or things like that, but it's important to go back in the winter time and make sure that things are stable. You don't want to see your fans cycling up and down. That's going to cause wear and tear on your fans, on your unit, on all your mechanical devices, that constant expansion and contraction. And we did a study about this a few years ago. And on our microchannel coils, we could see expansion rates of up to 3/4 of an inch on the hot gas side of the coil. So imagine your coil, doing this for 6 months, a year. So you're wasting energy, you're damaging your unit, and obviously your compressors probably don't like that either to be cycling like that. So I wouldn't say that there's no setting on our unit. There's nothing you need to do physically to our unit for any season because it only cares about one thing, the outside air temperature. And it will turn the water on and off based on that. But it's just the system as a whole that we'd like to see the system as a whole. It's not just the condenser, it's a whole system.
Yeah.
So everything that we change down here affects up the condenser.
Okay, because like I've set up lots of condensers on the HFC side, dry gas cooler, and we always ran the first two year round, even at minimum speed, on variable speed for that expansion and contraction, right? Because we see leaks on those headers all the time. Do you see that in a lot of setups where even in the wintertime, you'll have them run it, the very closest one to the headers running, or are they all off on your systems? That's one question. Or is it a mix of both? The closest ones to the header.
You mean the fans?
Yeah, the fans.
So all of our fans run always at the same speed.
Okay, so when I'm controlling that, I don't just control, just say it's 8 fan one. Mm-hmm. I'm not controlling just 2 and then another 2, another. You're ramping all 8 up and down. Can you change that if somebody wanted because there's too much air? Because I've seen this run into an issue, like you just said earlier. The customer thinks a bigger gas cooler is better, but if I have 8 fans, even at the minimum speed of 5%, that might be too much. Can they separate them if they want, or what is your thoughts on running that? Because this is a low ambient issue, and I've seen it on multiple gas coolers in different locations where that 5% is just still too much. Any thoughts on that?
No. So our units do not have partitions, so you could technically turn off a breaker for a fan. Each fan has its own individual breaker, but obviously that's not ideal because now you're creating a bypass. So the air is always going to try to flow through the path of least resistance, which is going to be now that fan that is off.
Yeah.
So yeah, it might help a little bit, but efficiency wise, I mean, if you're looking at your power consumption, it's just not. It is cheaper to run 8 fans at 5% than to run 2 at 50%. The math is in there.
Yeah.
So yeah, the other thing that we noticed, like Al mentioned, it was heat reclaim. So sometimes we recommend customers to turn that down a little bit if they're having capacity issues. It might be more efficient for the building as a whole to turn down your heat recovery system for your HVAC or something like that, and then run your fans at 5%. Or, I mean, there's multiple things that can be done. Yeah, but unfortunately, our units, the condensers, we don't have partitions between the fans.
We do like a lot of split condensers here for CO2. You know what I mean? So now that's another strategy where in the US, I don't see a lot of that yet. It's more started, but here in Canada, there's lots of split condensers. So you're removing, not even using half of it, which makes sense because it does get cold here sometimes. So Another thing that I've seen too is like before the water, all the water comes on, the fans have to potentially be at 100%. Is there any strategy before the fans? Because we said a temperature of say 72, the water comes on. Does the fans have to be at 100% before that comes on, or is that a strategy up to the manufacturer or the contractor?
So sorry, go ahead.
Apologies, Greg. Yeah, no, I was just going to say the fan speed, again, being controlled by the customer is completely independent of the water side system. So the water is just on and off based on the ambient temperature.
Yeah.
That being said, you won't be able to command the water on unless the fans are running. So sometimes during startup or pre-startup, customers want to check operation of the unit. They call, they say, hey, we think the pumps are bad. We keep trying to turn on the water system and it's not turning on. But the reason is because they're not sending any fan speed signal. So if the fans aren't turning, you're not going to get the water system on. So that's one caveat. We also have two, I'll call them canned sequences of operation built into the system. One is called energy saver mode. And what that does is that it will command the water on if your fan speed is over 35%, even if we haven't reached the ambient temperature set point. So basically, it's going to keep your fan speed at 35% and below, using water to save energy and run the fans more. The other side of that is the water saver package or water saver control sequence, excuse me. And in that case, the water won't be allowed to turn on unless the fans are above 90%. So again, that's another sequence that we have built into the unit. If the customer wants to save as much water as possible, you enable that feature. And then even if the ambient temperature is above the switch point, if your fans haven't reached that 90%, it's just going to keep using straight air heat rejection and won't turn on the water until we've reached that 90% fan speed. So those are two little sequences that they come in every unit. It's available for customers to use, but most people are just controlling the fan speed based on the control algorithm from the rack controller.
I love it. So what's your thoughts on which one they should use or even try? Because this is good to test, right? This is when you're doing a startup and a customer should test these different options, because I see this a lot in refrigeration. Like control manufacturers build all these cool energy saving algorithms, but nobody really always uses them, not a lot of time. So what are your thoughts on those two? What should they try and test, and how do they actually even turn that stuff on if the control like the manufacturer of the equipment has a control algorithm going to it? Can they do that, or is there options for them to test this stuff out there?
Yeah, so as far as the energy saver and water saver fan speed control scheme that I mentioned, that's as simple as approaching the HMI interface on the unit and just enabling that feature, just turning it on or off. Which one they should try? That goes back to my point earlier about what's most important, right? Is the facility manager staring at the water bill? Is he staring at the electric bill, or is he looking at it from a holistic standpoint? So yeah, you could also try 1 month to the next and see the results and compare if you're monitoring your energy and water use. But yeah, like I said, it's hard for me to answer as far as what's more important for the end user. I try to let them decide.
Yeah, great. Greg, thoughts on that?
Yeah, so I want to say probably like 80% of our customers running on default mode, and like I want to say the other 19.9% use water save mode. Mostly customers in California, in places where water is very, very expensive.
Yeah.
Obviously, like I was saying, now you only run water if your fan speed is above 90% for over 10 seconds, 15 seconds, something like that. So that works awesome in units that are slightly oversized, because I know it's opposite to what I said before, but what happens is now, if you have more dry capacity, obviously you can sustain your set points for longer. So it depends on a lot of things, and it depends on environment cost of water, obviously.
Yeah.
It depends on what the customer wants to do. Another thing to keep in mind is that EC motors are highly efficient. They barely use any power. So sometimes running fan in some situations, running the fan at full speed. Like some of our customers do actually, it's more cost efficient because remember the main thing that consumes power in the system is what? Is the compressor, right? So you're trying to keep your compressors happy. So sometimes it's cheaper just to run the condenser at full speed, full blast all year long, as long as you keep your head pressures down, and then you're saving money on your compressor side.
Yeah. Yeah, for sure. Because we always want to keep it below the critical point as much as
Absolutely.
possible. Subcritical. And then in the winter months, we don't want it to run too low. Like you guys said, we got that valve, holdback valve, and that comes into play with the gas cooler to make sure that our pressures, we don't get too low, because if we get too low, then we get oil issues and we get compressor issues, which you guys probably get called for. It's like the gas cooler issue, but actually it's not necessarily a gas cooler issue. Because this would be another question, I guess. When do I know, and you get these calls, I'm sure, when is it a refrigerant or a mechanical issue that is not a gas cooler side, or when is it a water, or when it's a gas cooler issue? And I'm sure you get these calls because you're like, I'm not a refrigeration technician and you want me to do a refrigeration job. When do you see the difference between that? Like it's actually a refrigerant issue or a refrigeration issue versus a gas cooler, adiabatic gas cooler issue?
It's never the condenser's problem.
No,
so
good answer.
So honestly, like you said, I'm not a refrigeration technician. But what I have seen, I get one of the common calls that I get is the condenser lost capacity. So it was working fine for 2 years, and now today it doesn't meet set point, and my head pressures are through the roof. So we have a case, and again, we could spend hours talking about this. We had a case in Phoenix, Arizona. It was like 119 degrees outside. We got a call. The unit doesn't have capacity, but it had capacity months ago. But now today it doesn't. So when I showed up, long story short, what happened is that the pads were installed upside down. And I think I don't think we have talked about this in this podcast, but we talk about it during the classes. So what happens is that you lose your adiabatic capacity. So obviously, if you think your condenser is not meeting capacity, check the pads, make sure they're installed upside the right way. The other thing that we have seen is that sometimes what I usually do when I show up on a site like this, where the customer complains about lost capacity, I would just look at the gas, whatever gas it might be. It could be CO2 or anything. I would look at the pressure on the pipe, and I will look at the temperature, and I will compare it to a chart, to a CO2 chart or whatever gas. So sometimes, if you have CO2 at, 1200 PSI, but it's at 50 degrees, I mean, is that CO2? No. Yeah. I mean, and again, I'm not an expert on this, but I can tell. So what could that be? Could be that you have non-condensables in the system and things like that. So again, those are the things that I check. Again, I'm not an expert on that stuff. I'm not a
no, but I love that, right? Because I know you get the refrigeration calls, and it has nothing to do with that. So let's just, before we end here, because I could talk to you guys all day. I love this. The pads are really important. Like you said, they could be put upside down. Do they have to mark them? How do they recognize that they're upside down or not? Should they be writing on while they're dry? You don't do this while you're wet, but should they mark in all the positions where they are? Because that's really, because you talked about already, the very top piece has like angles on it where the water goes in to a certain point, and it spreads it out through the pads appropriately through all the things. If you see the water just dropping off the pads and not going down the pads, that's an issue as well. So do you want to talk about how to properly put them on and take them off maybe?
Yes. So the pads have, and I have a picture. I don't know if I can share my screen really quick, or do we have time for that?
Yeah, share your screen. I would love it. Because I know this is a big, I've seen people send me videos, and it's like it goes down a quarter of the pad and then it's dropping right off onto the ground. Like it's kind of flying off the pad, not absorbing into the pad. And that is actually an issue, right? Because we want to wet the pad as best as possible. And if we don't, then we're losing capacity. We're not doing this job. We're losing efficiency.
Yeah. So I'm having a hard time.
While Greg's looking While Greg's looking for that, a couple of things that could be, Trevor, what you just mentioned is like the situation Greg mentioned where the pad's upside down. You don't have that water distribution piece at the top that spreads the water over the pad and allows it to fully soak in. It's easy to see. It's like a separate piece of cardboard box that's at the top, so it's very easy to identify. Another issue with water escaping the pads could be potentially too much flow going over the pad. And the way we control the flow depends on which type of unit we're talking about. On our smaller units that are a single fan wide, we use an orifice plate in the pump. So depending on if you have a 2-fan versus a 4-fan unit, it's a longer run that the water has to travel. So there's a different orifice plate to adjust the flow rate. So if there's a pump replacement and the technician didn't install the correct orifice plate, it's possible you'll have too much or not enough water for that size unit.
Okay, so how could a technician tell which one it should be? Is there like a code on it, or like how do they know that?
Yep.
Like,
so there's like little bumps, kind of like Brell marks, and the 4-fan unit doesn't use any plate. The 3-fan unit uses the one with 3 bumps. The 2-fan, 2 bumps. The single fan with 1. So try to make that simple. But if you're not aware of the orifice plate even existing, it's easy to skip that step.
Yeah. Great. Greg, are you able to share?
No, I'm sorry. We don't use Zoom. Like I don't.
It's the share button's down the bottom middle. So it's a little green button. So
oh crap! Yes, I saw it. Okay. Never
Yeah.
mind. Yeah. So I'm going to share actually my presentation for NASRC. Can you guys see it?
Yep.
So
Yep.
as you can see in this picture, okay, you can see it now, right?
Yep.
So you can see how the top of the pad is slightly different. So that is the same material. It's just glued sideways on top, and that helps spread the water evenly across the whole area of the pad. If you don't have that, what you're going to have is straight lines of water going down from top to bottom, and then you're going to lose 50%, 60% of your capacity because you're only wetting, 40% of the pad. And I know that doesn't sound like a big deal. It sounds like it makes a huge difference. I mean, you basically lose like 50% of your capacity just by doing that. And we have seen it many times when the pads get installed.
Dry spots in the pads. Yeah, dry spots in the pads with that will also contribute to increased scaling too. So it's not just efficiency, but also a potential maintenance item.
Okay. Very, very important to understand. Any other tips? I know you got the slides up here now. Is there a few extra tips for the technicians out there that'd be servicing or maintenance this, Greg?
Well, so a lot of customers are worried about, to take the pads, I have to shut down the rack, I have to close the store, things like that. So what we recommend is doing this early in the morning, let's say 5 in the morning, whatever, as early as possible. The units will most likely not be running water that early in the morning, unless you live in an area that is 80 degrees at 5 o'clock in the morning, which could happen. So that's the best thing to do. Another thing is when you open the control panel, you can kill power to the low voltage, to the controller PLC, all the 24, 120 volts, and leave power onto the fans. They will stay on at full speed forever, basically. So there's a way to do this without having to shut down the store or the rack, which is just leave the fans running, kill your low voltage. And now you're letting the fans dry up the pads, right? Because they're running at full speed with the pumps and the water off, and you don't have to worry about them turning on suddenly. So once the pads are dry, you take them off. You take one side out first. You clean them with your power washer or your hose. You let them. What you do is you're gonna let one pad dry on the sun, and if they're not too heavy, you can actually install them when they're still wet, because the unit will help you dry them off. But do not install all of them because they're not going to fit again, because they're they have expanded. They're a little bit too wide still, and that will help accelerate the process. Because we usually tell people just to let them dry in the sun, but then technicians would say, well, then I'm going to lose 8 hours.
Yeah,
you know what I mean. Another way to accelerate the drying process is to install them when they're still a little wet. Do not. I mean, you still have to be really careful. They're like when they get wet, they get softer. So you don't want to have your fingerprints. Your fingers will literally leave marks on the pads. You want to try to avoid that. But if you're short on time, or it's a CO2 system, you need to hurry up. That's another way to help. And then you're always going to let them dry before you install the last pad. You don't want to push them in or have them to get damaged. And then you do the other side of the unit, obviously.
Yeah, great tip. I love that, because that now you're being efficient with your time. Mm-hmm. Don't push them in, don't damage them, and get them dried out, because they all do need to be dry before.
Yep.
Awesome. Awesome. Okay. Well, we're gonna have to do this again because I still have more questions, but I love this. Any final thoughts? Any tips you'd like to give technicians, either new out there or technicians who are going to be tackling these gas coolers at some point? Any final thoughts, Al?
I would say, I mean, I think at this point, most people, especially in the supermarket business, most technicians probably have seen some kind of adiabatic cooler. But we still do talk to some folks who don't have any experience. I guess don't be afraid of it, right? I know it's different. It looks different, but read the manual, like you said. Give us a call. Greg and I are both here to support and help the field. We spend a lot of time doing training sessions, both through NASRC as well as directly with customers at their sites. We want the field to be comfortable and to be experienced and confident working on this equipment. So if you're not and you need some help, give us a call and we could set something up. We're happy to help.
Awesome. Greg, any last final thoughts?
No, same thing that Al is saying, and also I would like to know also what technicians want to learn about what they want to know. I don't know. It probably happens to you, Trevor, a lot. Like sometimes we have groups of technicians who want to learn about like thermodynamics, and they want to learn more about the science behind it. Some technicians just want to learn how to replace a pump, which is fine. I mean, whatever it is, but sometimes it's hard to get feedback because I don't know if it happens with you. Sometimes I have mixed groups. Some people just want to know, like the basics. Some people want to go a little more in deep, and sometimes it's hard for us to judge, how a presentation should go, what should we talk about, things like that. So that feedback, definitely will be appreciated.
Well, our next, because your background is mechanical engineering, next one will be the thermodynamics of the gas cooler. I think would be a good one that we could kind of chat about, just understanding what's actually happening in the gas cooler when the fans start to stage up and stage down. Because it doesn't really matter to the refrigerant at that point. There's something happening in that gas cooler. Why do you design them this way? You were part of the design team, Greg. You know what I mean? So why did you design them in this way? So we could probably dive into that because I can give you some tips as well as people that ask me what they're looking for. Because you're right. Some people are new to this and some people have a lot of experience. And sometimes it's hard, even in my CO2 training program, I have some advanced people and some newer people, and getting them all to the same point to get a result that they're looking for. That's what I try to do too. So it's sometimes it's hard, but we just try to make it fun for everyone. How can people get a hold of you or get a hold of a support or the manuals if they want to learn more about BAC?
Well, so we have a website,
right.
But I guess it depends on the question.
So, like, if they want to find the manuals, where would they go? Just say,
so there's www.baltimoreaircoil.com, and then you go to adiabatic products.
Okay,
and there's a manual in there.
Okay,
it's a PDF, and there's brochures. Like, there's a lot of information.
Yeah, so that's one step. And so if they need a call, like for support, just say that they need some help. They go through all of what we talked about today. They check the sensors, they check the faults, they check the pump, but they're really stuck, and they got a list of things that they already checked. Make sure before you call them, you're checking all the things that we talked about first, and then because you want to have a checklist before you call any support team, any manufacturer. You want to already do something before just calling. Is not working. You need to have that. Where would people go to a website, or is there an email address or a phone number that they can call for support?
So we do have a phone number, and I apologize. I don't know from the.
That's okay.
It was recently created in our company, but we can share it.
I'll put it in the comments below for any technicians that are looking for that support. Once again,